Welcome to Honors Geometry, Lesson 9.5, Composite Transformations, where we do more than one transformation at a time. Alright, go ahead and write this down. I will start it back up in a minute. Alright, I'm going to try to show you. I talked about it in class. Yeah, maybe I did, maybe I didn't, but I'll show you a way to make a glide reflection. Alright, here it goes. Okay, so first thing you need to do is move that along a translation, and now you need to flip it along a line that's parallel. Okay, and you just keep on moving. Another glide reflection. There's the glide. There's a reflection. And as you keep doing that, you just keep on making a new picture, and it's like footprints in sand. All right. Another significant one is a double reflection in parallel lines. Okay. X and Y are parallel lines. If the figure is reflected over two parallel lines in succession, then the result is a translation such that B double prime is perpendicular to X and Y and has twice the length of the distance between X and Y. So why don't we go ahead and find what the distance is between X and Y. We'll do that first. Okay. I don't know, can you guys even see that? Don't know if you can see it here. I'll make it bigger so you can see it. Alright, there you go. Now you should be able to read those numbers. Okay. The distance between X and Y looks like it's 4.2. Alright, so let's go ahead and reflect ABC in X. You get A prime, B prime, C prime. And now we're going to reflect A prime, B prime, C prime in Y. And you get A double prime, C double prime, B double prime. And you know what? Doesn't that look like a translation? It just looks like ABC was just completely slid all the way over. Now let's find out how big B prime is. According to the theorem, it should be 8.4. Look at that, 8.4. Wow, sometimes you luck out. But it certainly does look like a translation. Just slid right over. And that is what's going on. Okay. And then also there could be another cool thing happens when you double reflect over intersecting lines. If the figure is reflected over two intersecting lines in succession, then the result is a rotation such that P, the intersection of lines X and Y, is the center of rotation, and the angle of rotation is twice the acute or right angle formed by X or Y. So if X and Y intersect at a right angle, then the rotation would be 180 degrees. If the intersection is not at a right angle, then we're going to look at the acute angle. So it would be this angle right here. The angle of rotation will be twice that. So first we're going to reflect over this vertical line here. And when we do that, we get A prime, B prime, C prime. Now we got to kind of tilt our head a little bit and reflect it about this line Y. And we get A prime A double prime, B double prime, C double prime. And if you look at it, it looks like we've kind of turned this triangle about P as the center to get there. And what is that angle of rotation? Well, why don't we go ahead and look. First thing that we need to do is look at, alright, I need a couple of lines. So what we need to do is draw AP, and we also need to draw A double prime P. Draw those two. That is the angle of rotation. Alright, so let's go ahead and measure that with our handy dandy compass. Put that right on the vertex right there. Rotate this puppy out. And it looks like that angle is 94 degrees. The angle of rotation looks like it's 94 degrees clockwise. Now let's look how big the angle is formed by X and Y. And look at that. 46, almost 47 degrees. Okay, I'm off a little bit on that one, but hey, not that bad. Alright, let's look. It says 46. And this says, oh, that says 93 or 94. 93. Okay, we're really close. Alright, now this does not exhaust the different composite functions that there may be. There may be combinations of rotations and reflections and the like. There's all kinds of different composites, and you'll have a couple in your homework that you will have to do. So this does conclude lesson 9.5, composite transformations.